Page 456, number 17. Represent the complex number graphically and find the trigonometric form of the number. And we're given the complex number 5 minus 5i. Well, I know I can graph this on a set of axes where we have our real coordinate and the imaginary coordinate. 5 minus 5i means 5 in the direction of the real axis and negative 5 in the direction of the imaginary axis. So 5 minus 5i is this point right here. Okay, so that's the first thing we're asked to do. Second part, find the trigonometric form of the number. Now the trigonometric form of the number can be written this way: r times the cosine of theta plus I times the sine of theta. R stands for radius, which is, like if we think of a circle centered at the origin through this point, that's this distance right here, so that's R. Well, we can find that distance. Theta stands for the angle that this segment makes with the x-axis. Theta can be written either this way, all the way around the circle, or it can be written right here this way. Either answer is perfectly okay. Now let's just think about these dimensions here. I have 5 and minus 5. First of all, let's find r. We can use a Pythagorean theorem for that. So 5 squared plus 5 squared, which is 25 plus 25. So r is equal to the square root of 50, which, since 50 is 25 times 2, that's equal to 5 times the square root of 2. So there's the first part of our answer. Theta, to find theta, what we can do is say, hey, I know 2 dimensions of this triangle. So using SOHCAHTOA, I have the opposite and adjacent sides. I can say the tangent of theta is equal to negative 5 over 5. And I can take the inverse tangent of both sides to find theta. On this particular problem, I can notice that, hey, since these dimensions are the same, theta must be 45 degrees. Careful, it's not 45, but since we went downward here, it's negative 45 degrees. So theta is equal to negative 45 degrees. Now let's plug those into this trigonometric form. So our trigonometric form is 5 times the square root of 2 times the cosine of negative 45 degrees plus I times the sine of negative 45 degrees. Now if you want to check your work to make sure it's okay, you get out your calculator, and we can distribute this 5 square root of 2 times each of these quantities. So I can type in 5 times the square root of 2 times the cosine of negative 45 degrees. And there's my real part. 5 square root of 2 times this will give me my real part. If I do 5 times the square root of 2 times the sine of negative 45 degrees, I'll get my imaginary part. And there's my imaginary part. So if I distribute this 5 square root of 2 times both of those, I will get what I have up here, 5 minus 5 times I.